Okay, so here we look at the more complicated application of the sum of the roots and the product of the roots of a quadratic equation. So it says the sum and the product of the roots of the equation 8x squared plus h minus 1x equals k are negative 2 over 3 and negative 2 respectively. So find the values of h and k. So solution. So we know that for any ax squared plus bx plus c equal to 0, the sum of the roots is equal to negative b over a, and the product of the roots is equal to c over a. Now before we apply negative b over a and c over a, we need to secure that the equation follows the format ax squared plus bx plus c equal to 0. It means the terms are arranged in descending order and that the other side is equal to 0. So if the equation or the given equation is not in that form, we need to simplify the equation until it becomes ax squared plus bx plus c equal to 0. So let's take the given equation, and it saying that the equation is hx squared plus h minus 1x is equal to k. So clearly it's not in the form of ax squared plus bx plus c equal to 0 because the other side of this equation is not equal to 0. So what we can do is we subtract k on both sides. So we should have hx squared plus h minus 1x, so minus k, so on the left side, and minus k on the other side. So this will make the equation hx squared h minus 1x minus k is equal to 0. So at this point, it's already in the form ax squared plus bx plus c equal to 0. And we could easily determine the value for a is h, b is h minus 1, and c is negative k. Now according to the problem, the values for the sum and the product are already given. So it says they are negative 2 over 3 and negative 2 respectively. So this will imply that the sum, which is negative b over a, is equal to negative 2 over 3, and the product, which is c over a, is equal to negative 2. So if we will supply the corresponding value for a, b, and c, the sum will turn into, so negative b means negative of h minus 1 over a, so over h, is equal to negative 2 over 3, and that the product, which is c over a, so here we have c is negative k over a, which is h, should be equal to negative 2. So we need to solve each equation separately. So we continue with, okay, so on the first one, so this is the same as negative h plus 1 over h is equal to negative 2 over 3. And then if you multiply both sides by the LCB, 3h, so the left side will turn into, so h and h will cancel, so you have negative 3h and plus 3 if you distribute the 3, and then on the other side 3 and 3 will cancel, so you have negative 2h. And we still continue working on the equation. You have negative 3h, then if you add 2h on both sides, so plus 3 plus 2h, so minus 2h plus 2h. Then you now have negative h plus 3 is equal to 0. And then, working on this, we have negative h is equal to negative 3, which means h must be equal to 3. Okay, so in the second equation, we have negative k over h is equal to negative 2. So we can just multiply this by h on both sides. So on the left, the h will cancel, and you have negative k is equal to negative 2h. But since the first equation was able to give the value of h, which is 3, so negative k must be equal to negative 2 times 3. So negative k must be equal to negative 6, so k must be equal to 6. So we were able to find, so therefore, so the values of h, so therefore, the value of h is equal to 3 and the value of k is equal to 6. So these are the answers. Okay, so let's go back to the given problem and summarize the steps. So according to the problem, let's get it here. Okay, so the sum and the product of the roots are negative 2/3 and negative 2 respectively. So what we did, we transformed the equation into ax squared plus bx plus c, and that gave us hx squared plus h minus 1 x minus k. And all we did was to work on the equations that form the sum negative b over a and the product c over a. So we work on each equation until we solve the corresponding values for h and k. So we ended with the conclusion that h should be equal to 3 and k is equal to 6. Okay, so I hope you understand my explanation here. So this is just one of the application on finding the sum and the roots of the equation. So this is no longer a basic example into which just find the sum, find the product, but you're applying now the idea to solve an unfamiliar situation. Okay, that's it.